Okay, I want to start into solutions today. We talked a tiny bit about what a solution is a while back. And these are some of the slides from that. So basically, a solution is a mixture of two or more substances, solid, liquid, or gas, with each retaining its own individual chemical identity. In other words, once it's mixed, it doesn't change identity. The important point here is uniform appearance. That means that's that means it's going to be difficult to distinguish between the components of the solution. Now, solution is made up, and examples would be salt and water, alcohol in water like vodka, carbon dioxide dissolved in water for club soda, etc. Okay, now a solution consists of two parts, a solute and a solvent. Okay, the minimum solution is one solvent, one solute. But you can have more than one solute, only one solvent. Okay, basically it's the substance that's in the largest amount. So if you've got a 55-45 mix, the 55% one is going to be the solvent, the 45 is going to be the solute. Okay. Most of the time when people think of solutions, they're talking about an aqueous solution. Now, a solution can be any substances that are homogeneous, meaning you cannot tell the difference, okay? The air I'm breathing right now is a solution of nitrogen, which is the solvent because it's most, plus oxygen, plus carbon dioxide, hopefully not too much carbon monoxide, etc. A gold ring is made up of copper and, gold and copper. And they add copper to add strength to the metal because gold is pretty soft and it wears fairly easily, but it's a solution. Most of the time, again, when we talk about solutions, we're talking about stuff in water, an aqueous solution. Now, what happens is if it's an ionic substance, which most of the time it is, not all the time, but frequently it's an ionic solution, then the excuse me, then the water is going to surround both the cations and the anions. That's called a hydration sphere. Oops. Okay, and they have primary, secondary, tertiary hydration spheres. Okay. When an ionic solvent solute completely dissolves in water, it exists as a cation in an anion solution. Because they're ionic, they're strong electrolytes and conduct electricity. Okay, so that's a solution. Fairly straightforward. Most people have heard of it before. We've talked about it a little bit before. Okay, now I want to get into the quantitative aspect of solutions. Now, how strong a solution is basically how many moles of solute you have. The more moles of solute you have, the stronger the solution. Okay. And there's two kinds of solution concentrations. One's called molarity and the other's called molality. And molality is used a lot in chemistry in terms of colligative properties. In other words, when you put a substance in water, it'll freeze at a lower temperature and boil at a higher temperature. That's a colligative property, and that requires molality. Now, I'm going to focus not on molality, but on for our class. Okay, you're going to get into molality a fair amount when you get into 400. Okay. So molarity is usually expressed with a uppercase M, and that stands for moles of solute per liter of total solution. Total solution includes both of these. Okay, not just the water. Talking about a water-based solution. It's the water plus the solute. Because whenever you put solute in water, the water volume goes up. Just like when you sit in a bathtub, what happens to the water? It goes up. Okay. Now, the quantitative aspect of this is I'm going to be asking you how to make up solutions. And for example, and there are two ways to make a solution up. From a concentrated liquid, we're going to dilute it, or from dry ingredients. So we're going to go over the dry ingredients first. In other words, we're going to take a dry ingredient, like in this case, sodium chloride, and we're going to put it in water. And I want to end up with 2.1 liters of 5 molar sodium chloride solution. How do I make that? Okay, this goes back to what is the definition of molarity? Okay. Okay, that is the same as 5 moles in 1 liter of solvent. In this case, it's going to be 2,6-Vicks. Okay, but we're not talking about 1 liter, we're talking about 2.1 liters. Okay, but the ratio of solute to solvent of solution is the same ratio. So that ratio is the same as so we have a ratio problem now. Okay, so 5 to 1 is the same as what is the 2.1? Simple little algebra problem. Let's solve for x. Okay, so in this case, is we're going to multiply both sides by 2.1, so we're going to end up with okay, and what does that equal? Now this is, we're talking about 2,6-Vicks here. Okay, so it's my apologies for my cough. Yesterday I had a very bad time of it. 2.1 times 5 divided by 1. I'm talking about 10.5 moles. Okay, a 10.5 moles is how many grams of sodium chloride? Okay, that's going to be sodium is 22.99, and chloride, I believe, is 35.45. Yes. So what is that? 44. 58.44. Okay, so we're going to take that 10.5 times 58.44. So we're looking at, for 2 sig figs, 6.1 grams of sodium chloride. Okay, so how do you make up the solution then? So we're going to take in add now I'm going to say 1.9 liters of water and mix. Then bring the total volume up to 2.1 liters. The reason for that is when you add the sodium chloride solid to the liquid, it brings up the level of the liquid. So if you added it to 2.1 liters, your final volume would be more than 2.1. So that would be the answer to this problem. Okay. So we're starting with a dry ingredient. How much do we add to get the final volume at a certain concentration? Okay. Andrew, does that make sense?
Yeah, that makes sense.
Okay, so let's do one more of these, and I'm going to do a different version of this dry. Okay, so we have which is 2.34 moles per 1 liter. And that's equal to how many moles in 18 liters? Same process. So we have a ratio of 2.34 moles per 1 liter. How many moles per 7.18 liters? It's going to be a simple deal of cross multiplying, so we end up with and 1.88 moles and 188 moles times 58.44. We have your 1.88 times 109, 110 grams of sodium chloride. Now I have 110 decimal point because we're talking 3 sig figs here. The decimal point added, it made it 3 sig figs. Otherwise, it'd be 2 sig figs. Okay. So how do I? What are the directions here? Okay. So I'm going to add 110 grams of sodium chloride to less than 718 liters, let's just say 6 liters, as long as it's less than the final volume, and mix, mix, and then bring total volume to 718 liters. Now it's important to follow this process where you initially mix the solute in less than the total volume of water. Because if you don't, the final volume is going to be more than 7.18 liters. Okay, so what if we start with let's see here. Let's look at this problem here. Okay, we take 10 grams of salt in 2 liters of water, bringing the total volume of the solution to 4.75. What's the concentration of salt? Okay, now this is a little different take because we're just throwing in a bunch of dry salt into the 2 liters of water, bringing it up to 457 liters. What's the concentration? Okay, now remember, concentration is moles per liter. Okay, well, right now we can find out how many moles we have in 457 liters. Okay, so what we do is we want moles of sodium chloride here now. So we have grams converted to moles. So we're going 10 grams. And it was 58.44, wasn't it? This will give us moles of sodium chloride. And my calculator shows. Okay, so that's 25 point, I'm looking at 3 sig figs here. So that's, okay, so that's 25.8 moles in 457 liters. What is it moles in 1 liter? Okay, we're simply going to divide 25.8 by 457. Or okay, so we're approaching this dry problem one of 2 ways. One is I want a certain volume of solution at a certain concentration. How do I do it? The other approach is if I have a certain volume and I dump in a bunch of dry ingredients, what's the final concentration? But there's 2 steps to both of these. Okay, 2 steps. One is involving calculating, if we're starting with grams, we need to get to moles, and then divide the total volume into that total moles. Or the other one is converting the moles to grams. Okay. Let's do one more of the latter. Let's just make one up here. Okay, so we're dumping in 345 grams of dry sodium chloride to 23.4 liters of water. What's our final concentration? Okay, so first thing we're going to do is convert. Final concentration is going to be in moles per liter. So we need to get that grams into moles. Okay, so first step is 345 grams. This will give us moles of sodium chloride. And that's going to be okay. And that's all going to be in 23.4 liters of water. We want to know where it is for 1 liter. So that means we're going to divide 23 into the 0.590. So we're going to hit So we're looking at days. Okay, so those are the two variations of dry ingredients. Using dry ingredients to get to our solution. All right, the other approach is taking a concentrated solution and then diluting it. Okay, so what we've already done is we're taking dry ingredients. Now we're going to take and dilute a concentrated one. Okay. The basis of this calculation is if we start with 5 molecules, and we increase the volumes, this is say 1 liter, we increase the liter to say 6 liters. We still have 5 particles, or the mole of particles equals, all we've done is we've increased the solvent. We haven't increased the amount of solute. So the solute moles has not changed. Now, if we know the concentration of this, and this is going to be our concentrated, And then we know okay, so that's going to be the dilute. This is going to be the concentrated. So if we multiply so if we know the concentration of our concentrated liquid, we multiply that by the liters, concentrated, we end up with moles of this concentrated. You just said that the moles of the solute are equal. That means we can set that equal to the final concentration that's dilute times the volume of the diluted one, which is 712. And that's going to be, okay, so basically this is our unknown here. How much of the concentrated do we add to bring it up to 7.12 at 5.23 moles per liter? Okay. So this is going to be basically M times V dilute equals M, this is dilute again, equals, what's it, right over here. So we have the concentration of the real concentrated liquid. We have the volume of the concentrated liquid. This gives us moles of the concentrated, which is equal to the moles of the dilute. So we have 4 variables. I gave you 3. You solve for the 4th one. So how would we do this then? Okay. So basically, we're gonna solve for this amount of liters, or the volume of the concentrate. So how much of the 24 molar stuff do we add to make up a 5.23 molar solution at 7.12 liters? Okay, so then we're going to divide both sides by 24. Okay, so those cancel, leaves us with liters of the concentrate. So we're going to take 523 times 712 divided by 24. We're looking at 155 liters of concentrate. Then we're going to bring the total volume with water to 7.12 liters total. So this is how you ran a chemistry stockroom, you buy concentrated acids. You don't buy dilute acids. And then you dilute them to whatever concentration you want. It's significantly more economical. And secondly, it saves lots and lots of acid. Excuse me, acid storage space. Okay, so let's do one more of these. Well, I don't know what this is here. Okay, let's say okay, so I want 23.5 liters of, let's say, 1.02 molar solution. Okay, and you have a concentrated solution of 4.56 to start. How would you make that? Okay. MV equals MV. MV concentrated equals MV dilute. That's the formula for doing diluting concentrated solutions. Okay, so let's see where we are. Yeah, okay. All right. So MV concentrate equals MV dilute. Okay. All right. So this is the dilute, and this is the dilute. This is the concentrated. And then we don't know how much is the volume of the concentrate. Okay. So again, it's MV, and that's concentrated, equals MV dilute. Okay, so we know the concentrated is 4.56 molar. We don't know the volume of the concentrate yet. I'm going to calculate that. We know the our final concentration is 102 molar, and our volume is 23 0.5 liters. So we're going to solve for the volume of the concentrate. So that's going to be 102 times 23.5 divided by 456. Okay, so the volume of the concentrate is we're looking at 5.26 liters of the concentrate. So what we're going to do is we're going to take 5.26 liters of concentrated sodium chloride solution and bring up final volume to 23.5 liters. And if we subtract 5.26 from 23.5, we'll end up with adding how much water. Okay? Andrew, does this flow okay for you? Okay. All right, I'm going to do one more problem. It's going to be harder than the last two. Okay. If I add 3.45 liters of 1.23 molar sodium chloride solution to 4.56 liters of 2.34 molar sodium chloride solution. What is the final concentration? Okay, so here here now I have okay, I'm going to call this solution A and this one solution B. Okay, so remember, okay, concentration is moles per liter. So what we need to do on this one is we need to find the final moles and the final volume. And then we can calculate this guy here. Okay, well, remember how we did moles up here, MV, okay? So MV for A is going to be MV for B is going to be and this will give us moles of A, moles of B. Add those together. Final volume is we have 345 liters for 56 liters. This would be volume of A, volume of B. So what's that? 3. Okay, so looking at for the final volume. Okay, the final moles is going to be this guy plus this guy. So it's going to be 345 times 123 plus 456 234. And that's going to be 11 2 moles. Okay, so now we have 11 2 total moles over a total volume of 8.01 liters. So what is that going to end up being here? Okay, so we're looking at 1.40 liters. I mean, moles per liter. Now that's a significantly more difficult problem, but we're basically, it's a wet problem. There's another variation on this. We could start with a liquid, and then we can add dry to it. That's already got some sodium chloride in it. A lot of variations on these. Okay, that's what I wanted to cover today. And my coughing actually did really well. I was anticipating having another coughing fit. Okay, so Andrew, any final questions?
No, not at the moment.
Did this flow okay?
Yeah.
Cool. Okay.